Today I'm going to discuss the behaviors and trends of the periodic table. We're going to talk about the elements found on the periodic table, some early history, and discuss the properties and patterns associated with those elements on the periodic table. So let's get started. In terms of history, we want to first look at the first initial investigations of the periodic table. Now, it's believed that Dmitry Mendeleev was the first scientist to actually publish and organize the periodic table of the known elements. He's now known as the father of the modern periodic table, but I'm going to tell you a few reasons why that is the case. Now, from a historical standpoint, Mendeleev was a little bit of a troublemaker. He got in trouble with the Russian government and the Russian Orthodox Church, but like many, he was kind of ahead of his time, and those kind of conflicts can kind of promote that kind of discourse or conflict. So, in addition to actually coming up with the organized version of the periodic table, he actually went on a limb and actually was able to predict the properties of elements that had not even been discovered, accurately so. And so, his predictions kind of led to the world accepting his ideas about the periodicity and the natural trends found on the periodic table on our modern periodic table. Now, he understood the concept of periodic law, and it was based on the premise that when arranged by increasing atomic number, the chemical elements actually display a regular and repeating pattern of both chemical and physical properties. Basically, you could take this forward and assume or look at it as an assessment that says basically atoms with similar properties appear in similar groups or families. Now, when we talk about the periodic table, you have these vertical cross sections, and on those vertical sections, they are referred to as those families, and they are grouped in families because they tend to exhibit very similar reactivity and very similar chemistry. And we'll get into those. Now, just kind of to add to that, the lateral name for the direction of elements going from left to right is called a period or series. And that's the cross section, whereas the vertical section is your groups or families. Now, with the groups and families, they're very similar because they all have the same number of valence, which stands for outer shell electrons, which governs this chemical reactivity, kind of what I said before. Now, valence electrons refers to the number of electrons in the outermost shell. These are generally the electrons that will engage in a chemical reaction. Now, hopefully you remember how to tell the number of valence electrons for elements found in both the S and P block. Generally, the group 1 has either one valence electrons or 2 valence electrons. And then when you get to the P block, they go as high as 8 valence electrons, with 8 being the operable number because everyone wants to achieve what's called octet. Now, there's a little bit of a variation when it comes down to D block elements and F block elements, and most of them may have 2 valence electrons, and then some only have 1 electrons. But you want to definitely be familiar with the S block and the P block electrons. Now, in terms of grouping, there's really 3 types of groups, I guess you could say, besides the 4 blocks of being S, P, D, and F respectively. We have metals, nonmetals, and metalloids, or perhaps semi-metals. And we're going to go forth and kind of just show the slideshow where we kind of discuss each group and discuss their properties and kind of go from there. So, again, you have your groupings of metals, nonmetals, and metalloids. And you want to kind of see that they are kind of color coordinated from this chart. I am going to go into specifics and talk about each subsection, but you definitely want to have familiarity with where these are located. For instance, one might be tasked with asking the question of you know, if a certain element is a metal, non-metal, or perhaps metalloid. And what does that mean in terms of its properties or behavior? So there's a zigzag or staircase line, and that line right here kind of divides the table, if you see where the mouse is following. Now, the metals represent this blue region, and your non-metals represent your orange region. Now, in the middle is the staircase, which is kind of your purple. And if you notice, the staircase kind of skips aluminum here. And I'm going to talk about aluminum later, but part of that is because aluminum exhibits more of a metallic character than metalloid characteristic. So, again, elements that border the staircase are shown in purple. Again, there is one exception, that being aluminum, and that's because, again, the aluminum has more of a metallic characteristic. I don't know if you've ever worked with aluminum foil, but it is lustrous and it exhibits some of the other characteristics that we're going to find out about that pertain to metals. So that brings me to my next series of questions. How do you identify a metal? What are its properties? What about the less common nonmetals? What are their properties? What is a metalloid? So we're going to talk about metals first. Metals are lustrous. That means they have the ability to reflect light. They're malleable. They can be conformed and arranged. They're ductile. And they're good conductors of both heat and electricity. Most of them are solids, with one notable exception being mercury. Now, when we look at the group of nonmetals, they're pretty much the exact opposite. They're dull, they're brittle, they're not good conductors. And while some are solid, many of them are gases, and bromine is actually a liquid. Now, as I kind of alluded to before, metalloids share very similar characteristics to both metals and nonmetals. They're not quite one or the other, and they have characteristics of both metals and nonmetals. So some are shiny but brittle, and they can be semiconductors, which means they conduct some electricity, but not as efficiently as some of the other metals out there.